Here we're going to go over unit conversion and dimensional analysis. This is something that we always do at the start of every chemistry class because it's a good thought process. Now you might get the idea that if you're not good at this, you won't be good at chemistry, and that's not true for a couple of reasons. One, chemists do not spend all of their time converting from one unit to another. And two, this is an important thought process and it's something that you get better at through practice. You are going to be responsible for metric to metric conversions, which means that you're going to have to convert from one metric unit to another. You're not going to be asked to convert from English to metric units without a conversion factor. We're going to reuse this thought process in lots of other ways, and like I said before, practice is something that's very important. I've used 3 red arrows to make that clear. As we begin, let's think about a few different things. First, we're going to treat units like numbers, which means that we can cancel them out through division. We're also going to reference metric prefixes, so knowing them would be a good thing. For simplicity, we're going to look at prefixes as either fractions of or multiples of a base unit like a gram, a meter, or a liter. So on the right, we've got giga, mega, kilo, centi, milli, micro, nano, all of which are multipliers of a base unit like a gram, a meter, or a liter. Being familiar with those is going to be very handy. Here we're being asked to convert from 6.50 grams to kilograms, and we can do this in one step because there is a direct conversion between grams and kilograms. We start with what we're given. 6.50 grams, you write that in the numerator. Now, we want to get rid of those units of grams, so we're going to put those in the denominator, and we want to adopt units of kilograms, and those units are going to go in our numerator. Because grams are in our numerator and denominator, they cancel out. And now we need numbers to make this make sense. Every 1 kilogram is 10 to the 3rd grams. So we know that from our table over here, and if we put this into our calculator and do it right, what we see is 0.00650 kilograms, or 6.50 times 10 to the minus 3rd kilograms. Both of those are right, and they both have the same number of significant figures, which is also correct. Let's move on to a second example, a double step. Here we're being asked to convert from 6.50 times 10 to the 8th milligrams to gigagrams, something very small to something very big. And again, we don't really have a single conversion that takes us from milligrams to gigagrams, but we can break this up into 2 single-step conversions. So we just need one more step in our little fraction thing here. Let's start with what we're given, 6.50 times 10 to the 8th milligrams. We want to get rid of those units of milligrams and change that into units of grams because there is a single step conversion for that. Then we're going to take those units of grams and convert them into units of gigagrams. Again, a single step conversion. So this double step is really just 2 single steps. Now, the units that appear both in the numerator and the denominator, like milligrams and grams, they will cancel. So now let's just put in the numbers to make this make sense. Every 1 milligram is 10 to the minus 3rd grams, and every 10 to the 9th grams is 1 gigagram. So we know these all from the multipliers there on the right-hand side of our table. If you plug this in into your calculator and get it right, you should get 0.000650 megagrams or 6.50 times 10 to the minus 4 megagrams. Both are correct. Think about this. We broke these conversions down into single steps. Metric conversions themselves are just multiples of 10. That number 6.5 never changed because these are always and only multiples of 10. And at the end of this, you want to ask yourself the question, does this make sense? That is, what I'm getting, should it be a bigger number or a smaller number than what I started with? And that has a lot to do with the unit you're converting from and the unit you're converting to. Now that you have that done, try this one. It's a little bit of a challenge. I'm asking you to convert 42 megaliters to microliters, a very big unit to a very small unit. If you do this correctly, you should come up with an answer of 4.2 times 10 to the 13th microliters. I hope you've enjoyed. We'll see you in class.